Okay, class, we're going to go over just 3 homework problems, I think. The rest we'll go over when I come back on Thursday, because these 3 problems really encompass everything. And a lot of the other ones are easier problems, and you're welcome to compare answers with each other. So let's do these 3 problems because they both, all 3, excuse me, have sector area as well as the pizza crust. So that's going to really help you out, I think. Okay, and hopefully you did the warm-up triangles in the previous section for homework. And I told you to watch videos if you don't know how to find the area of some basic triangles, but I am going to cover it here. But hopefully you've already done it, and this is not going to be crazy difficult. Okay, so to find this pizza crust here, we need to first find the area of this purple sector, the sector area, okay, that whole big slice, which includes the triangle and the pizza crust. So let's do the sector area. Now this is a 60-degree arc measure, so that makes this a 60-degree angle. It's really hard to see because it's so small. All right, so I know that it's going to be what? So the sector area is going to be equal to 60 over 360, in other words, 1/6, right, of the area of a full circle. Now the radius is 4, so it's going to be pi 4 squared. Okay, now if we reduce the first fraction, it's 1/6, and 4 squared is 16, and I like to put the 16 pi in the front. Now one big trick I've showed you before is to make this fraction times fraction, because remember, this 16 is in fact in the numerator, whereas the 360 is the denominator. Of course, that 360 is reduced to 6, 1 over 6, I should say. Okay, so that equals 16 pi over 6, and that does reduce, right, to 8 pi over 3, and we can leave it unreduced, right? That's fine. 8 pi over 3. Okay, now the triangle area. Well, this is an equilateral triangle. I hope you know this. We've gone over this many, many, many times. You needed this for the project, so I'm going to pretend that everybody knows this. And I don't see a good picture of it in equilateral triangles. Oh, there it is. Okay. Okay, so to find the area of an equilateral triangle, let me just scroll down a little bit. Find the area of an equilateral triangle, right? And we'll use the actual dimensions in our problem here. It is 4. It is 4. So it's 4 by 4 by 4. But the base is going to be split into 2 and 2, right? Because we have to draw an altitude. That's the key here. We have to draw an altitude right through the middle. Okay? All right. There's a right angle here. We know all the angles are 60, right? So this angle here is 60. And this big angle at the top here is 60, but it's being bisected, so it's 30. So it's very important, and this you recognize in an equilateral triangle, that there's two 30, 60, 90s if you break it up like this. This is the short leg, right? And of course this is the long leg, so this is 2 radical 3, and the hypotenuse is still 4. But for the area of this triangle, right, it's 1/2 the base times height. So in the right triangles, it's 1/2 times the base times the height. The base is 2. I'm sorry, the base is not 2. The base is 4. All the way across is 4. So the base is 4. And the altitude, which is what we spent that time doing, was 2 radical 3. 2 radical 3. Okay, the 1/2 times 4 is 2. So that's 2 times 2 radical 3. And that's 4 radical 3 total. Okay, so that's the area of the circle, of the triangle, excuse me, the equilateral triangle. So this is 4 radical 3. So very simple, as we went over yesterday, to find this shaded region, which I nicknamed the pizza crust. It's the sector minus the triangle. So all we can really do is do 8 pi over 3 minus 4 radical 3. Now you can get a common denominator here, right? And you can put this over 3, so it'd be 12 over 3. And make it a single fraction, and that's actually more preferable of a method, but I'm just going to stop here. I expected most of you only to get this. There's no units here, so I'm going to just use units squared. There's no units, so I'm just going to put units squared. But if it was meters or centimeters or something like that, I would definitely put that in there, okay? So when you see the answer key, the teachers are going to get a common denominator of 3 here, make that 12/3, and make it a single fraction. But that's okay. For now, that's fine. Okay, in this problem, the sector area. Well, this is actually a very easy sector because this sector here is a quarter of a circle. Really no work here, right? It's 90 over 360, but I'm just going to put a quarter of a circle times the radius. Times the area of the circle, which is pi the radius squared, right? Okay, so that's going to be 100 pi divided by 4, so obviously that's 25 pi. And again, there's no units, so it's units squared, right? So, and I should have that here too, units squared and units squared. Okay, now this one was 25 pi units squared. Okay, the triangle is, it's not an equilateral triangle, right? This is a 45, 45, 90 isosceles right triangle. Very simple because the two legs are 10. So the triangle area is 1/2 10 times 10, which is 50. I almost wrote 100. 1/2 10 times 10, which is 50 units squared. Very simple. And so finally, again, sector area minus triangle area is 25 pi minus 50, and that's units squared. To be really proper, we should really have parentheses around these because the unit squared applies to the entire term, see? And then this one, we're going to draw an altitude here. Okay, and we're going to have to actually show this bigger picture, right? We're going to have to make a bigger picture of this triangle. Okay, so this is a 120-degree angle in here, but if I split it like this, see, and I put a right angle in here with 12 and 12. If I split the 120-degree angle, this is 120 here, that's 120 here, but if I split that, it would be 60. And of course, this is 90, and that's 30. Okay, and now we have a 30, 60, 90 triangle where the hypotenuse is 12. Hopefully you remembered that or looked it up. That makes the short leg 6 and the long leg 6 radical 3. And of course, that makes this leg 6 radical 3, see, from here to here. Okay, so the area of this triangle, it's kind of on its side, is 1/2. I know I skipped the sector. I'll get to that in a second. But the area of the triangle is 1/2 the base. The base is this whole big thing down here. That's 12 radical 3 because 6 radical 3 plus 6 radical 3 is 12 radical 3 times the height, which was 6. This height here was 6. We found that earlier, okay? So we put this triangle on its side. We draw an altitude, even though it's horizontal. It's still an altitude if you look at the triangle on its side. We use 30, 60, 90 rule to find that, and we get this, okay? Half of 12 is 6. 6 times 6 is 36, so it's 36 radical 3. The sector area is a 120-degree sector, so it's going to be 120-degree central angle, which is 120 degrees for the sector. So the sector is going to be 120 over 360, which is 1/3, times pi r squared. Okay, so basically we get 1/3 of 144. And I don't think that reduces. I could be wrong, but I don't think so. So that's it. That's the sector area, 144 pi over 3. And these are both units squared, because no units were given. Okay, and then the shaded area is just what? The sector minus the triangle, right? 144 pi over 3 minus 36 radical 3. And the whole thing is unit squared. The teachers, again, on the answer key are going to have a common denominator here, which is actually more proper. And then put them together. Okay, so if you can do these three, you should be able to do all the other problems on the worksheet. We will be posting an answer sheet for that, and I will go over any questions on that when I come back on Thursday. So in the meantime, let's learn some new stuff, okay? So we're going to just do other, I'm going to call it 7, 6, and we're just going to call it other areas, other shaded regions, really. Other areas, shaded regions. Okay, so I showed this in class yesterday, so this should be a quick review for you. I showed you when you had a square and you had a circle inscribed in the square, roughly like this. Okay, and we wanted to find this shaded region here. Now, I already did this in class with you, so I'm going to show you like another problem, right? So I'm going to make it a little trickier than we did in class. I'm going to say, what is that shaded region there? Okay. All right. Well, before we do that, let's do the whole shaded region. So I showed you this in class. I said, how would you find this shaded region? Well, and I don't know if well, whatever it is, I'll give you 10. I'll make it 10 right now. Okay, so I'm going to say it's 10 across here, and of course it was given to you that it's a square. Well, it's obviously a square because the circle touches all four sides. So, what is that shaded region? Well, you guys figured it out in class, luckily. It's the area of the rectangle, or in this case the square, so it's the area of the square minus the area of the circle. Very simple. That will give you the shaded region. Well, the area of the square is 100. That's 10 times 10. And if that's 10 all the way across, then this is 5. You're going to be doing a lot of this on the homework, see? And let's make this meters, just because we want to have some units for once. Okay, so that's a radius of 5 because it's 10 all the way across. See, the diameter would be 10. If it fits perfectly in a square like this, it's going to be 10. Or it's going to be equal to this length. So the diameter is 10, the radius is 5. So the area of the circle is pi r squared, right? So pi 5 squared, which is 25 pi. Okay, that's the answer to the problem. I am going to put meters squared just because I label this with meters. Okay, so you should know how to do that. On the homework, there's going to be a double one. There'll be a double one like this. You can take a look at the sheet. Don't forget 7.6 is already on the drive, so you're going to download that for homework tonight. And there might be another circle in here. Now, it's not a great picture, but you get the idea, right? If I did all that, it's just going to be 2 diameters across and 1 diameter vertically. I think you can figure that out pretty easily. Okay, I'm actually going to go back, though, and I'm going to do the problem that I said I was going to do, which is, how would I get just one of these? See, just one of these. So if somebody said to me, what's the area of the shaded region, and it's only a quarter of this, well, I would do the exact same thing I did. See, I would do this again. This is for all of them, right, all 4. And you notice that it's all symmetrical. So this is literally 1/4 of the answer we got here. See, so I would just multiply my original answer by 1/4. Now it's not going to be pretty. Okay, so that's going to be, we'll shade this red so you can see the difference. Okay, so that would be the red shaded area. Okay, now if you distribute it 1/4, you should be careful here. This will be 25 minus, now you can't take 1/4 of 25, so it's just going to be 25 pi over 4. Okay, meters squared. Okay, now what your teachers are going to do, I'm going to actually do it here, is I'm going to find a common denominator. So I'm going to say change 25 to be 100 over 4. See, that's equal to 25 minus 25 pi over 4, and condense that into a nice simple fraction. Well, okay, it's not simple, but a more condensed fraction, and then put meters squared there. And that's a more proper form of the same answer. Okay, another very common one is 2 circles. So let's take a look at that, or even 3 circles. Okay, or even 3 circles. Like, I think you'll have homework 3 circles in your homework. Okay, but we'll start with 2. And somebody wants to find the area of this ring. Okay, the area of a ring. Okay, well, just like before, and just like many of the homework problems, right? And let's give you a couple numbers here. So let's say that the inner radius is 3. Okay, and then I'll just say that this is 1. That's actually not a radius. See, that's not a radius. So if we were to break this up into 2 circles, you'd get the white circle on the inside, right? And then you'd get the whole big circle, which would be this whole thing. See, so that whole picture is the red one. Okay, and then the white one would be the inside one. And of course, to get the shaded region, we're going to subtract big circle minus small circle. Okay, all right, so the big circle is pi, the area, right? This is the area of the big circle, is equal to pi r squared. But what is r? Well, for the big circle, it goes from here all the way to here. How much would that be? That would be 4 because somebody labeled this as 3 and the separation is 1. Okay. And of course that's 16 pi. Now the area of the little white circle, right? We'll do a different color here. So the can't do white, of course, but the area of the circle, but this is the white circle, right? The inner one, the smaller circle, is going to have a radius of only 3. In other words, from here to here is 3. See? So that was going to be pi 3 squared, which is 9 pi. So finally, the area of this ring, right, the area of the ring is the 2 circles subtracted. That's going to be most of your homework is subtracting the 2 areas. So the area of the ring is equal to the big circle, 16 pi, minus 9 pi. Okay, and I think the final answer is 7 pi. And we are going to call this unit squared. I don't think I put any units on there. Okay, that's how you do a ring, and there'll definitely be a ring in your homework. Let's do one more, right? So another thing that can also often happen is if they give you a circle and they put a triangle in it, right? So they put a triangle like this, for example, right? Let's make that solid. Okay, so there's a few problems like this. Well, a couple of things. Well, I didn't give you any dimensions yet, but yeah. So let's make this arc. Let's make this arc over here. We'll make it 60, right? 60 degrees. Okay, and we'll call this a radius of 5, which is from here to here, of course. And let's say somebody wanted this shaded region. See, it's actually 2 pizza crusts, and you can do the problem that way, but there's a much easier way to do it. I mean, you can certainly use the pizza crust concept here. But the easy way to do it is to just do what? And let me show you the highlighter. Is to find the area of this. See, all of this, right? That's the area of a half circle. And then subtract this, the green. See? And you'd be all set. Okay? So the area of the yellow, which also includes the green, is just a half circle. It's just half of pi r squared. They gave me they gave me the radius to be 5. So that's half of 25 pi. So that's 25 pi over 2. Okay? Now the triangle, right? The triangle is actually a 30, 60, 90 triangle. How do I know that? Well, this is in this arc is 60. This is inscribed angle. So I messed up. Inscribed angles are half the intercepted arc. That's 30. Now this angle here, and I warned you about this. Anytime you have 2 rays that hit the endpoints of the diameter, right? Because this is 180 degrees because of the diameter. See? So this angle in here is going to be half of that, which is 90. And if it's 30 and 90, you know the other side is 60. And if that's 5, then this would be 5. Right? They gave you this 5 radius, so it would be 10 across. And the short leg is half the hypotenuse. So this is going to be 5, and this is going to be 5 radical 3. Okay? Rules of a 36, 90 triangle. So the area of the triangle is, I don't know why I wrote 1/3. Oh, yeah, 1/3, okay. We found the area of let's label this. See, this is the area of half circle, right? That's the half circle. And we want to find the area of the triangle, okay? So area of the triangle of this triangle here. And the area of the triangle is, in a right triangle, it's always 1/2 the 2 legs. See, the 2 legs. 1/2 times the 2 legs. So the 2 legs are 5 and 5 radical 3. Okay, 5 and 5 radical 3. Okay, and that basically just equals 25 radical 3 over 2. And that's, again, I think units squared. And that's the area. It's not the area of the triangle. It's the area of the shaded. Okay. All right. So armed with these three examples, right? This example, the ring example. By the way, you know, there might be three circles, right? There could be another circle out here, and they ask you to find that ring. Or, you know, and depends on which rings you want, but it's always the inner and outer edge of the ring, those two circles. So in this case, the circle with a radius of 3. In this case, the circle, excuse me, with a radius of 4. You're just going to subtract the two. Or the third example we did, I thought we did 3 examples. Yeah, this guy, of a circle inside a square. You know, another one that could happen, I'm not going to go over the problem. You could have a square inside of a circle, right? Inside of a circle. You could have a square inside of a circle. And the only thing I'm going to warn you about here, I'm not going to use any numbers, I don't think, is if somebody gives you a problem like this, and they ask for the shaded region on the outside here, right? If somebody asks you for this shaded region, well, you're going to have a couple things to do. You need to find this length, which will be the radius. See, that's the radius. Okay? So, for example, if the square had a side of 10, okay, then if I kept going like this and made a triangle, I'd have a right triangle with 10 by 10. And it's a 45, 45, 90. We know that because it's isosceles and has a right angle in it. And the 45, 45, 90 rule, which I know everybody knows, is you take the leg and multiply it by radical 2. Okay? So in this case, the area of the square is easy, right? It's just 100. Again, units squared. 100 because it's 10 by 10. That's right, the rectangle. And the area of the circle, right? The area of the circle is going to be pi r squared. And this is a toughie, you see? If it's 10 radical 2 all the way across, see, that's the diameter, then the radius is going to be 5 radical 2, right? Half of that. So this is 5 radical 2. And here comes a real doozy. We've done this before. How would you square this? You would just multiply it by itself, right? You'd multiply it by itself. Okay? And that equals 25 times radical 4, right? So pi times 25 times radical 4. But of course, the square root of 4 is 2, so this is going to be 50 pi. 50 pi, and I'll put units squared. 50 pi for the shaded region. If they only shaded one of them or two of them, for example, you could do 1/2 or 1/4, depending on what they ask you, so not too hard of a problem. Okay, so armed with that, you've got 4 examples now. You should be able to do the bulk of your homework. Don't get bogged down on the 7-6 sheet, okay? It's on the drive. You can download it right in Notability. It will also be on the website. I'm sorry, it won't be on the website. The video will be on the website, but this will also be on Backpack sometime tomorrow afternoon. Okay, but you should download it right now from the drive and work on this. So go back and fix any problems from 7.5 that you may not have finished, or start 7.6 using the 4 examples I gave you here. And please show work, and I expect you to try the problems, even the ones I haven't shown you. They all use the similar concepts of subtracting 2 areas. Okay, I'll see you guys on Thursday.